Tuition Mobile, quality e-learning experience on the go.
Hello and welcome to today's class. Our topic for today is captioned inequalities. Inequalities. And without wasting your time, we'll quickly go into rules for solving inequalities. Okay. The rule number one states that when either sides of the inequality is multiplied, or divided by a negative sign or a negative real number, okay, the inequality sign is reversed. Okay, so for example, what we are talking about here is that, for example, if you are given that 3 is less than 4, okay, which is logically correct, multiplying both sides by negative or minus sign, okay, will cause the inequality sign to change, and then we have minus 3 and will be greater than minus 4. Okay, and so what we intend to explain here is that numbers on the negative side of the number line detects that the lesser the negative number, the higher it is, but the higher the negative number, the lesser it seems to be. Alright, and so if we take another example, maybe we have that minus x is less than 13, okay, and then we multiply both sides by negative. Alright, and we will now have that x will be greater than minus 13, okay, because negative times negatives gives positive, and then negative times positives gives negative, and then we have x is greater than minus 13. Rule number 2 is called the inverse rule. Okay, and the inverse rule states that if a is greater than b, then the inverse of the two numbers, that is 1 over a, will be less than 1 over b. Okay, then this goes a long way to describe and explain the fact that 1 over a bigger number is less than 1 over a lesser number. For example, if a is equal to 5 and b is equal to 2, alright, logically 5 is greater than 2. But then when we take inverse, that is 1 over a less than 1 over b, okay, it implies that we have 1 over 5 will now become less than 1 over 2. Alright, so also it doesn't really matter if they are negative numbers. Okay, let's find out what happens if they are negative numbers. It implies that minus 2 will be greater than minus 5. Okay, but when we take inverse, 1 over minus 2 will become less than 1 over minus 5. Alright, okay, let's go over to rule number 3, which we call the addition rule. And then if a is greater than b and c is a real number, then we have the following. then number 1, we can state that A plus C will be greater than B plus C. Okay, having already stated that A is greater than B, adding additional and equal values to both sides, okay, does not change the inequality sign. All right, let's take for instance where our A is equal to 3.5 and B is equal to 2.8 and then C is equal to 2. Fine. So all we are saying is that from the former we can say that 3.5 is greater than 2.8. That's to depict that A is greater than B, and then trying to depict that therefore A plus C greater than B plus C will imply that A plus C, that's 3.5 plus C, which is 2. Okay, will it be greater than 2.8 plus 2? We'll find that 3.5 plus 2 is 5.5. Okay, let's see whether it's greater than 2.8 plus 2, which is 4.8. Alright, it's obvious that 5.5 is greater than 4.8, so this law holds. Okay, maybe let's consider that from the negative aspect point of view. Can we also say that for under this addition law or the addition rule, can we also say that A minus C will as well be greater than B minus C? Okay, that is removing a defined and equal units of a real number from both sides. Will it still give the same outcome? Let's find that. And suppose we still use A to be equal to 3.5 and then B to be equal to 2.8 and then C to be equal to 2. Alright, therefore we can say that A minus C greater than B minus C will imply that we have A 3.5 minus C, which is 2, and then greater than B 2.8 minus C, which is 2. And so from here we have 1.5. Will it be greater than 2.8? Because we have 0.8 as the outcome here. Yeah, so 1.5 is greater than 0.8, and so this applies. Had it been it doesn't hold for this, then it means the sign, the inequality sign, needs to be changed. All right, go over to rule number 4, the multiplication and the division rule. The multiplication and division rule. Alright, so we can say for the multiplication and division rule there are many implications here. We have that A is greater than B and C, if A is greater than B and C is greater than 0, which means C is a positive real number. Okay, and it then states that AC will as well be greater than BC. Alright, a positive real number, those real numbers without a negative sign, they're positive real numbers. And so let's try to illustrate this using the fact that well, as well say let A be equal to, alright, let's take A to be equal to 4 and B to be equal to 2 and then C2 to be equal to 2. Okay, 2 is a positive real number. Alright, let's find out what happens on AC greater than BC. Okay, let's see whether this implies AC greater than BC. will have A4 and then C2. Let's find out whether it will be greater than B2 and then C2. Alright, 4 times 4 is 8 and then 2 times 2 is 4. Alright, this holds. So we can say that when we have two positive numbers being multiplied, the sign doesn't change. Alright, let's check for some other conditions under the same multiplication and the division. But what if C, the multiplier, is a negative real number, in the sense that it is less than 0? Okay, let's find out what happens if it's a negative real number. Maybe C here is minus 2 and then we still use what we had above. Then let's find out AC, will it be greater than BC? Okay, it implies that we'll have A, which is 4 times minus 2, and then will it be greater than B, which is 2 times minus 2. Alright, let's find out 4 times minus 2 is minus 8, and then 2 times minus 2 is minus 4. Alright, remember what we said, that that the lesser the negative number, the higher it is. So we sure know that minus 4 is greater than 8 on this, so this sign does not hold, and then it reverses, and then therefore it changes to minus 8 less than minus 4. And so we can say that for negative, for C less than 0, okay, it implies that AC will be less than BC. All right, and then we go into some other illustrations under the same multiplication and division number 3. Let's find out what happens if A is greater than B and C is less than 0, okay, under division. All right, for example, if A is greater than B and 6 less than 0, and then we'll take real numbers, we'll take real numbers to denote them, like we had let A be equal to 6 for this, and then let B be equal to 3, and then let C, which is a negative real number since it's less than 0, be equal to minus 2. And so therefore we can say that, let's find out what happens to A over C, okay. Let's see whether it will be less than B over C, okay, or whether it will be greater than A over C will be greater than B over C. All right, so what do? A is 6 and then B is minus 2, okay, and then let's find out whether it's less, and then on this point B is 3, while A is minus 2, okay, and so we have minus 3 on this side. Let's find out whether it's less than minus 1 whole number 1 over 2. Wow. Or is it less than or greater than? So we know the one we are taking to imply this law. All right, look, observe this very well. You find out that the lesser the number, the more the value, okay. The lesser the negative real number, the more the value. So this applies. Minus 3 is less than 1 over 2, so we take this, and so we are taking this, but this does not apply. All right, so all we are saying is that when a negative number divides both sides, okay, the right hand side, the sign changes. All right, when a negative number divides both sides, the sign changes. Okay, under the same multiplication and division, let's check out what happens if A is greater than B and C is greater than 0. Okay, let's find out whether A over C will be less than B over C, or A over C will be greater than B over C. All right, let's find it, and using the same illustration above to denote our A, B, and C, and so A over C is 6 over 2, okay, because here C will be equal to 2 because it is greater than 0. It's a positive real number, and so let's find out whether it will be less than 3 over 2. Okay, this is as good as saying that we have 3 less than equal to 1 whole number 1 over 2. Is that possible? That does not work. So for this the sign will have to reverse, and so 3 will be greater than 1 whole number 1 over 2, and so the one that applies for this is this. So therefore we can say that if we divide by a positive real number, A over C will be greater than B over C. Okay, over to the next slide, and then we have to check for signs. We have to check for signs, the rule of signs of products. Rule of signs of products. Okay, all right, this rule is useful. It is useful when we want to deal with algebraic expressions where A and B are involved. Okay, where A and B are algebraic expressions. Okay, I'll write expressions, and then in bracket I will indicate that they are algebraic expressions. Okay, not just mere expressions. All right, so it states that the first rule there states that if it's positive sign, for positive signs, okay, if AB is greater than 0, all right, hence there are two things that can work out here. It's either A is greater than 0 or B is greater than 0. Okay, sorry, I think this should be and b is greater than 0, or a is less than 0 and the b is less than 0 too. Okay, this follows from the logic that if they are less than 0, when two positive negative real numbers multiply, minus a times minus b multiply, the signs cancel out. Okay, number 2, what if they are negative signs? For negative signs, if ab is less than 0, okay, it implies that it is either a is greater than 0 and the b is less than 0, or a is less than 0 and the b is greater than 0. Okay, and so you should know that there must be a combination of both positive and negative. There must be a combination of both positive and negative numbers, and negative real numbers. Alright, and from there we go into graphical representation of inequalities. Graphical representation of inequalities. Okay, alright, under graphical representation we'll be talking about number lines. Number lines are used for representing linear inequalities. They are used in representing linear inequalities. Okay, there are two types of number lines. The first is called the open inequality. Alright, with a hole and an empty space. Open inequality. This happens when the inequality is of the form x greater than 3, and then we have the closed inequality. The closed inequality is a cycle with shaded portions. Okay, alright, that's with the line, and then we call this the closed inequalities. It comes when the inequality is of the form x greater than or equal to 3. Okay, so what determines whether it's open or closed is the sign of the inequality. And so for example, we'll be taking the following examples. We have for example 1, we have to represent this inequality minus 1 less than x less than or equal to 2. We use both closed and open inequality, and so we have open and then the closed inequality. Alright, we have the 2 points clearly indicated. On the extreme left we have the minus 1, and on the right we have minus 2. And then number 2, let's represent this inequality 2. We have 1 less than x less than 2. Alright, the both sides are open inequalities. Okay, so we don't need to shade any of the cycles. Okay, and then number 3, on the open inequality we have a minus 1 less than or equal to x and then less than 2. And so you find out that the extreme left end is an open inequality, and then on the right hand side is a closed inequality. Sorry, the left hand side is an open inequality, and then the right hand side is a closed inequality. And so for number 4 we have minus 1 less than or equal to x less than or equal to 2, and so the two ends are closed inequalities. Closed inequalities. And so you have minus 1 and 2 closed inequalities. Alright, so since we now know this, we can take some examples combining all the facts we've gathered together. Example number 1, you are told to illustrate the inequality given. Illustrate the inequality minus 8 less than minus 2x less than minus 2. Solution: whenever you're given an inequality, try to simplify them, okay, to move from their complex form and then to look simpler. Minus 2. Alright, the way you can simplify this is to divide all sides by minus 2, so that to get rid of minus 2 attached to x, alright, the coefficient of x there. Okay, minus takes care of minus and 2 takes care of 8 to give 4 less than, and then minus takes care of minus and then 2 takes care of 2 to give x. Okay, and so minus takes care of minus here and then 2 takes care of 2 to give 1. Alright, remember what we said, that when a negative value divides an inequality, the sign changes. Okay, so the sign changes from greater than to less than, and from less than to equal to greater than to equal to 1. So, and then we can rewrite this equation to as well be equal to 1 is less than or equal to x, and then less than 4. Alright, and so trying to represent this on the number line, we have a closed-ended part on 1 and then an open-ended part on 4. Okay, and 1. So this is my number line, assuming these points are 2 and 3, so that here is 4 and then here is 1. Alright, we'll take another example and then we'll end the class there. Example number 2. Example number 2, we have to solve the inequality. Okay, minus 4 less than or equal to 8 minus x less than 3x plus 10. Okay, and so all we have to do here on the solution part is to try make ourselves understand the inequality given. We have minus 4 less than 8 minus x less than 3x plus 10. Okay, look at the inequality. Well, it means that minus 4 is less than or equal to 8 minus x, or that 8 minus x is less than 3x plus 10. Alright, and it is advisable we solve separately at this point. We solve the inequality separately. Okay, and so this part will be for minus 4 less than or equal to 8 minus x, and then this part will be for 8 minus x less than 3x plus 10. Okay, and so starting right from here, I will add x to both sides of the equation, and then this becomes 8x plus x, and this takes care of x from this side, and then here becomes minus 4 plus x less than or equal to 8. Fine, and then I'll add 4 to both sides to take care of 1. Then here becomes 4 minus 4 plus x plus 4 less than or equal to 8 plus 4. Okay, and so 4 takes care of 1, x is less than or equal to 8 plus 4. Alright, so that x is less than or equal to 12. Okay, and then to this side I will add 3x to both sides, and then I have 8 minus x minus 3x. I'll subtract 3x from both sides. It's less than 3x plus 10 minus 3x, and this takes care of the 3x, cancelling it out, and then you have 8 minus 4x less than 10. Okay, and then I'll try to subtract 8 from both sides, so I have minus 4x is less than 10 minus 8. Okay, because removing 8 from this side, and then the other side you have minus 4x is less than 2. And so I want to make x more of the subject of formula. All I have to do is to divide both sides by minus 4. I divide both sides by minus 4, and then minus 4 takes care of this, and takes care of the signs too, and here becomes x. Meanwhile, this -4 changes this sign from positive to negative, and hence changes the equality sign, makes the equality signs to change from less than to greater than, and then becomes -1/2. And so look at the two outcomes. You have that x is less than or equal to 12, and then x is greater than -1/2. So we can rearrange it this way, that 1/2 is less than x, meanwhile x is less than or equal to 12. Alright, so it gives us the inequality that 1/2 minus is less than x, and then x is less than or equal to 12. Okay, so with this we have come to the end of the class. On our next class we'll be talking about graphical methods of inequality. Thank you.